Welcome to another video. In our previous video, we introduced the first of several econometrics papers that are bringing machine learning methods into econometrics. And in this video, I wanted to continue that with one of my own papers that covers the topic of sample selection correction. And this paper is useful for high-dimensional choice set situations where we have many alternatives, and we want to account for the fact that the information that we see about the chosen alternative is non-random and potentially subject to some sort of sample selection, which would bias our estimates. If you've heard of the Heckman sample selection correction method, this is highly related, but brings in some machine learning into the method. So if you go back to 1979, that's when Heckman's famous paper about sample selection correction was published. And the canonical example here is that we only see the earnings for people who are employed. And this could distort our estimates of, say, the returns to skills, because maybe the less skillful people are the ones who don't have a job right now. And so the question that my paper is asking is, can we improve on this by machine learning? And especially if we have a much larger choice set than a binary employed or not employed. So just to review what Heckman's basic procedure is, we model a selection decision as a utility maximizing process. So we have some variables that might explain whether somebody's working or not. And then we estimate, say, a probit model of that utility maximizing behavior. And this model will give us probabilities of choosing each option. And then we can use that information from those probabilities to form what's called an inverse Mills ratio, which is a ratio between the PDF of a normal distribution and its CDF, or 1 minus its CDF. And then we can basically put this inverse Mills ratio term into our outcome equation, our wage equation, and that will give us selection-free estimates of the betas that we want. So this lambda term of z times gamma hat is going to be plugged in as if it was any other regressor, and then that's going to correct for the selection bias. So what are some limitations of this approach? Well, we have to assume that the taste shocks are normal, that are governing the selection process, and that the outcome equation shocks are normal. We also need to have some sort of exclusion restriction. So we need some variable to affect the utility part, but not enter the productivity part. And then it's also very difficult to extend this to a multinomial choice setup, because we can't just use this simple inverse Mills ratio if we have many alternatives. So the paper that I published in 2021 is looking at migration in the United States and selection into major choice. And there's a high dimensional choice set here because there's many different places that people can live and work in. And the key idea is I want to know what's the return on average to choosing a particular college major. And it's understood that individuals are choosing where to live both in terms of their wage and non-wage factors. So maybe I'll take a pay cut to live closer to my family, for example. But the problem is that the researcher only sees the wage in the chosen location, and so that's going to distort estimates of the return to this college major that's chosen. So we have this potential selection bias that's contaminating the wage returns. And so if we think back to the Heckman model, we have this inverse Mills ratio that corrects for selection. But we could generalize this to a multinomial choice, and non-normal error terms. And there's a paper by Gordon Dahl in Econometrica in 2002 that proposes this approach. So he proposes that we have some flexible form of the selection probabilities. And then DJ here is just a dummy that the person chose option J. And so the question is there a better way to get these probabilities? Because in Dahl's paper, the probabilities are a simple bin estimator that could be overfit or subject to sparse cell sizes. So we take these selection probabilities, which are just the predicted probability of choosing option J, and we could generate that any way we want, non-parametrically or using a probit model or a multinomial logit or whatever. So we take those probabilities, and in particular, we're looking at the first best choice. So what's the probability of making the choice that I saw you make in the data? And what's the probability of choosing the next preferred alternative as measured by the next highest choice probability? And what I do is I use a classification tree model to obtain these selection probabilities, and then make an assumption that people with similar Z's and similar P's have similar tastes. And then from there, we can include these terms in a fairly straightforward way in the outcome equation to get selection corrected estimates. And so this is an improvement on this Econometrica paper that I was mentioning. And we can include a lot of Z's in our model without encountering the curse of dimensionality, because the tree model can merge sparse cells together through this regularization. And so they're going, because there's this adaptive partitioning, they're going to merge neighboring cells to make sure that there's not a small cell size from the curse of dimensionality. The machine learning aspect removes the researcher's requirement to pre-specify the rules for grouping these different bins. And the paper could probably be even more generalized to have some sort of model selection aspect on those selection correcting probabilities, those lambda tilde of P's. And so maybe that's an option for future work. So if you're watching this video and that sounds interesting to you, you can reach out to me and maybe we can write that paper together. So this is another example of the broader idea that we can bring machine learning tools into econometrics in specific ways that can improve the performance of the econometric analysis. In the next video, we'll cover a highly popular method known as double debiased machine learning. This is something that I believe is used at nearly every tech company these days. And so it would be useful for you to learn about this as well. And so I hope to see you in that video.